Hello, I want to welcome you to this class. In this class, we are going to look at 2020 Physics JAMB past questions. Okay, all the 40 questions. We are going to use this video to analyze them. I promise you, you will see some repetition. It might not likely be exactly word by word, but most of the questions are coming from past exam. And the one you are going to write, you might see some question here. So pay attention and look at the way we analyze everything. If you have any question, drop it in the comment section. Don't forget to subscribe and share this video with your friends and loved ones. This one says, the figure below shows two boxes placed on the top of a table. If the boxes are equal in weight, it can be deduced that A, the pressure exerted by A is greater than that of B. So one thing we should take note of here now is we are talking about pressure. When it comes to pressure, you should know that pressure is equal to force over the area. Now what you should take note of is, if we are told that the boxes have the same weight, it means here will be constant for two of them. Okay, that is F will be constant for two of them. So what varies now is the area. So you can see in this place, this area is wider than this. Let's assume that this area is 4. The area of this is 2, for instance. And now let's assume that the force, that is the weight of each is the same, that is, let's say 10-10. Because this and this, as we are told, they have equal weight. Because they have equal weight, we put 10-10. Now, this one has wider bottom. That is wider area. We put 4. This one lesser one, we put 2. Which one do you think is bigger? You find that if you divide this now, this will be smaller than this. So the smaller the area, the higher the pressure. It means once you divide this, you have 5. This will be less than 5. We are calculating the pressure. It means the pressure of this guy is higher than the pressure of this guy. Okay? So therefore, without even reading the question, you can tell us that what the pressure exerted by B is greater than that of what? A. So B is the correct answer. Okay? Look at this second question. It says, a ball of mass 0.5 kg moving at 10 meters per second collides with another ball of equal mass at rest. If the two balls move off together after impact, calculate the velocity with which they do this. So what you need to see here is that this ball was moving. As it was moving, let's say this is the ball. Let's call this ball with this mass M1 was moving in this direction. There is another ball, let's call it M2, that was at rest, that was not moving. So once this ball comes closer, that is now collide with this ball, two of them start moving in the same direction. If you understand physics, what they are describing here is momentum. And what is momentum? Momentum is M, that is mass, multiplied by velocity. Okay? The mass times the velocity. This first ball, the mass is 0.5 kg. And the velocity is 10 meters per second. Okay? The second ball, equal mass. It means this one has M as equals to 0.5. But because this was at rest, it means this is what? 0. It was not moving. After the incident, two of them started moving. Right? That means they combine together to move. The question is says, At what velocity were they moving together? You get it? So what we need to do now is, before the collision, the total momentum is equal to the momentum after collision. That is what? The law of conservation or linear momentum. So therefore, before the movement, mu, let's say 11 plus mu 22 is equals to the combined mass now, they combine together, but we don't know this v. Okay? The combination multiplied by, look at this as 1 multiplied by v. So now, we know that this is 0.5. We know that this is 10. We know that this is also 0.5, but this is 0. Then here, we know that this is 0.5 plus 0.5 v. Now we are looking for v. This is already gone. This will give us 5. So this one is 1 v. V therefore is equal to 5 meters per second. So that is what the question is asking us what to solve. This is what the combined velocity of the two bodies after collision. Hope you understand this. Let's look at this. It says, which of the following energy conversions take place when a catapult is used to project a stone? You have a catapult used to project a stone. While you stretch it, you stop. What is that? That is stored potential energy. Once you release it, the stone, you are converting that stored energy to kinetic energy. Okay? Now let's see the option. The elastic potential of the catapult is converted into kinetic energy. Exactly. The gravitational potential energy is converted into elastic. No. Kinetic energy of catapult. No. The catapult is converted into kinetic energy of the stone. The catapult. But this was removed from this. Some people will mark this in a hurry. Is this that is converted to this. Potential to kinetic. That is the physics in this question. There is no physics here. Catapult. What is catapult in physics? There's nothing like that. Okay? Hope you understand this. Let's look at this. It says, which of these equations gives the relationship between a linear speed, v, and angular speed of a body moving uniformly in a cycle of radius r? For this, you simply do v as equals to wr. That is all. wr. So, is there anything like this here? This is the answer. Okay? Let's look at this. It says what? A cell can supply current of 0.80 amps and 0.4 amps through a 2 ohm and a 5 ohm resistor respectively. Calculate the internal resistance of the cell. One thing you should know is that when you have a cell, they always have internal resistance. So if this is a cell, we put the internal resistance immediately, assuming that two of them are together. That's what you put in your mind, because they are actually one. They are one. We are just using this to represent them, but the resistance is inside the cell. So we use this resistor to represent it. So now, this one combined together is connected to external resistor. Say here 2. This is 0.8 amps. That is coming from here now is 0.8 amps. One thing you should note is this that is coming from here will flow through this, come back and flow through the internal resistance before coming back to the negative pole. For the second one, the same thing. Okay? So, but this time we have 0.4 amps. Internal is 5. And so, this one Remember, they are together like this. The question says calculate the internal resistance. This one is what they are asking us to calculate. Sorry, I am making a big mistake here. This is not, this is the 5 ohms. This is R. Okay? This is R. We're going to call this one R1, we'll call this one R2. Instead of say R1, it's the same R, because as you can see in this place, we are talking about the same cell. The same cell. The same cell. It's just that this cell was used to test 2 ohm. The same cell for 5 ohms. Okay? Now that we understand the question very well, it is time for us to solve. How do we get R? Very easy. This current is always equal to V over R. That is voltage over resistance. Okay? What is the voltage here? We don't know. Just say V. What is the resistance? The resistance is this resistance plus this resistance. Why are you adding them? Because they are in series. Series connection. Flow loop. So it's this R plus 2. We add them together. This current is what? The current is 0.8. So therefore, it means here now V is equal to 0.8 multiplied by R plus 2. Without wasting our time, you know what to do here now. We say here V is equal to IR2, IR. That is 0.4, which is the I, the R. But we have 2R here, this and this. We have together plus 5. Now, because the voltage of this and voltage of this are the same, because we are using the same cell, for God's sake, the same cell, then we equate these two. That is 0.8 R plus 2 equals to 0.4 R plus 5. Okay? So now, this here 1, this here, you agree with me, is 2. Remember, in exam condition, you don't do this because you are not meant to waste time like this. Because I have to explain, that is the reason why I am doing this. See, this is 1R, this is 1. So the answer is what? 1 ohms. 1 ohms. So it's 1 ohms. That is, you check very well, the answer is B, 1 ohms. Okay? Let's look at this question. It says what? What is the effect of using split rings in a simple DC generator? What is the effect? When you put a split ring, what happens is that the current in the coil flow in the same direction. This is DC. If it was AC, you use 2 slip rings. 2 for reverse movement. For the reverse, because it's alternating current. AC. But this is DC, direct current. So because it's direct current, the current in the coil flow in the same direction. In the same direction. Okay? Let's look at this question. It says what? It takes 4 minutes to boil a quantity of water electrically. Okay? How long will it take to boil the same quantity of water using the same heater coil but with the current double? You know your country no light, right? Maybe NEPA will bring light and the light is very low. You are boiling water. Later you want to boil the same quantity of water but double current. What will happen? Calculate it, physics student. One thing you should put at the back of your mind here is we are already talking about energy. Energy, energy, energy. That should be what should be ringing on your head. Okay? And you agree with me that energy is equals to power multiplied by time. Power what? Multiplied by time. But what is power? Power electrically is current R. That is current raised to power 2 multiplied by R. It means therefore this energy we can say is this RT. Okay? That is the energy. Why am I doing this? Because the energy that you will use to boil the first water is equal to the energy for the second water. What am I saying? For the water temperature to be here, and you move it to this temperature with, say, let's say 1 amp. That is the current, for instance, 1 amp. And you boil it again. For you to get to this same location, this energy and this energy are the same. The first energy, we don't care to know about the time. It's like we are saying you have a feed, okay? 20 people should clear it. The same feed, 100 people should clear it. At the end of the day, the feed is cleared. The same thing. At the end of the day, you boil the water. So the energy here and energy here are the same. So therefore, we are going to do now that what? This energy and this energy are equal, and this is our energy. So therefore, we say I square RT. Now we're going to call this one, the first one, I1, T1. These are, let me put this one first here before I explain that. This is 2, this is 2. Why am I not putting anything here? Because we are using the same ring. Whatever resistance in this ring, assume this is the ring, whatever resistance in this ring will still be maintained. We are using the same ring, for God's sake. So it is the same resistance in the ring that is resisting the current flowing, what? From flowing very fast. So therefore, we can say that this and this will cancel to have this. So next thing now is the first one. We are told that what is just I1. Okay? The time is 4. Now, this current is double. That means to get this, you multiply this by 2. That is 2I raised to power 2. Then, we don't know T2. Okay? Remember, this is 1 because it is this I1 we are using for this now. That is, if you double this I1, you have this. So if you expand this now, you have this 4 equals to, this is 4. I want to get here 2, then T 2. This and this, as you can see, cancel. This here 1, this here 1. It means therefore 1 is remaining here equals to T2 is remaining here. So here is what? 1 minute. 1 minute. You get it? That is that. The following are vector quantities except momentum. Momentum involves what? Mass and velocity. V is what? A vector quantity. Force involves vector quantity, has direction. This one, kinetic energy. Energy is just energy. Energy, power, whatever. Have energy. You cannot tell me that my energy is in north, west, southwest, or northwards or southwards. It has no direction. So, without wasting our time, it is what C. C is the answer. This one too, magnetic induction, has direction. Let's look at this. It says what? A plane inclined at an angle 30 degrees. Let's just draw a rough diagram. 30 degrees to the horizontal surface has an efficiency of 50%. The force parallel to the plane required to push a load of this upwards, 500 Newton, is what? What you must put at the back of your mind is this. Mechanical advantage. Mechanical advantage is always equals to load force over effort. Load force over effort. That is effort force. We are told that we have efficiency of 50%. What is efficiency? Efficiency, the mechanical advantage over the ideal mechanical advantage multiplied by 100%. Okay? So, but what is ideal mechanical advantage? Ideal mechanical advantage is the ratio of the slope. Is the ratio of the length of the slope, this slope you are seeing here, is the ratio of this to the height. Okay? This plane to the height. That is ideal mechanical advantage is, let's call this one H, let's call this one L. That is the ratio of what? This over this. I'm going somewhere. What are you seeing here now? We are seeing, if I say here now for this, I say opposite over hypotenuse. You agree with me? I will have opposite over hypotenuse. Okay? But here is the reverse. It means it's 1 over sine 30 degree equals to, we reverse this to be L over H to have exactly the same thing. So I can come now to replace this with this by saying the ideal MA is equals to 1 over sine 30 degree. So therefore, I will come back to this efficiency. I say it's MA now, again, over this 1 over sine 30 degree multiplied by 100%. You get it? So the next thing now is that, what are we even looking for? We are looking for what? The force required to push it upwards. That is what? The effort. The effort. And today we actually agree that this is effort. So we are coming back here to say effort, we cross multiply. You agree with me? At the end of the day, you're going to have effort force as equal to, they will swap, that is load force over here, we're going to have MA. Okay? This is what we are looking for. Load force over MA. What is MA? Let's find MA here. Let's find MA here. You agree with me? Here alone we have MA sine 30 degree. If I turn this now, multiply by 100%. This is efficiency. MA alone here, you agree with me, you're going to have efficiency over sine 30 multiplied by 100%. You understand? That is divide both sides by this to have this. Okay, so now let's continue. We don't have much to do again now. All we need to do is to substitute here. So what we are looking for is effort, right? Effort force. That is the force we are going to apply. It's equals to load force is actually what? So you can see the load is what? 500. 500. I'm solving it the way you understand. Then MA, don't remove anything. MA is efficiency. Efficiency over sine 30 times 100%. Okay? So therefore, 500 over efficiency is what? 50% efficiency. Let's go put that 50% efficiency. So here is 50% over sine 30 multiplied by 100%. You agree with me? This will cancel this. This will cancel this. This here 1, this here 2. So therefore I have 500 over 1 over sine 30 times 2. What is actually sine 30? Sine 30 is 0.5. 0.5. You agree with me now? We are having 500 over 1 over this will give us what? 1. 1 divided by 1 is 1. Okay, let me just make you happy. 1 less 500 divided by 1 again is 500. Do you want us to continue? So the answer is what? 500 Newton. 500 Newton. Okay, 500 Newton. Is there anything like that? Yeah, 500 Newton. Let's look at this. A man of mass 77 kg stands on a spring weighing machine inside a lift. When the lift starts to ascend, its acceleration is 2 meters per second square. What will be the reading in the machine? Let's look at something. If this is the machine and you are this person standing on it outside a lift, what you will see, the measurement you will see is simply mg. What is that? your mass multiplied by G, okay? Assume you are 80 kg. We say this is 10. You are going to see 800 Newton on the scale. That is okay. Now, we carry this scale. I put it inside a lift. This is a lift. This is the floor of the lift. We put the scale. We ask you to stand on this scale. You are standing on the scale. We are saying, when this starts accelerating, what will you see on this machine? What will be the reading? Two things are involved now. This one due to gravity and also the force required to pull you up. What you should not think is, what is required to pull you up is MA. Your mass multiplied by the acceleration of the lift. What is your actual weight is mg. It means the total that will be registered here is the addition of these two. The reaction is equals to mg plus ma, which you can easily say what? mg plus a, and our m is what? 77. G is, let's call it 10. If they give you G to be 9.8, you use. A is what? 2 meters per second square. You multiply these two. When you multiply these two, you agree with me, you're going to have 924 in Newton. 924. Okay? Let's look at this question. It says a dry hydrogen is trapped by a pellet of mercury in a uniform capillary tube closed at one end. If the length of the column of hydrogen at 27 degrees Celsius is 1.0 meter, at what temperature will the length be 1.20 meter? To do this, we need to use the Chance law. What is Chance law all about? It said that what V1 over T1 is equals to V2 over T2. Okay? So the next thing you ask me now is, what are we looking for? So you can see, we are looking for T2, this second temperature, okay? So we are going to make this one the subject of formula. You agree with me? I will bring T2 here. That is V2 over V1 multiplied by T1. Subject of formula. Now the next thing you ask yourself is that what is the meaning of volume? Volume is what? Area multiplied by height. Okay? Area, height. So that height, you are going to replace it by L. So that is to say, here is area multiplied by L, because that's what we are looking for. L2 over area L1. The area remains the same. Area of the tube multiplied by T1. So this and this will cancel. You agree with me, it's L2 over L1 multiplied by T1. Now what is, let me work it here. What is L2? The second one is 1.20. That is 1.2. What is T1? T1 is 27 degrees Celsius. But we cannot use Celsius here. We use Kelvin. That means we have to convert this now to Kelvin by adding 273 to it. So this one we convert it to what? Kelvin. This will give us 300. Okay? So therefore this one will be 300 in Kelvin all over L1. L1 is 1. That is 0.0. Okay? So just to multiply this by this. If you multiply 1.2 by 300, what are you going to get? You're going to have 360 Kelvin. And you agree with me that the answer is in Celsius. So what we need to do, we subtract 273 from this to have 7 here, 8 degrees Celsius. It means the answer is what? Is D. The answer is what? D. Hope you understand. Just start with Chance law. Remember to convert to Kelvin. Okay? Once you convert to Kelvin, also remember that volume is area multiplied by height. So if this is a tube now, this is what we are talking about, the height. This is the area that remains the same. Okay? The area remains the same. Because they told us what? It is uniform capillary tube, meaning that what? The area is the same throughout, okay? There's no change in the area. The reason why we make it A. Hope you understand this. Let's look at it. It says the nuclear number and atomic number of a neural atom of an element are this and this respectively. What is the number of neutrons in the atom? All we need to do is to write out what we already have. The nuclear number, that is the mass number, which you can also call the mass number, A, is equal to what? 238. Okay? Also, we are given the atomic number. Atomic number. Atomic number, Z as equal to 92. Okay? So with this information now, we know what to do. What are we going to do? The number of neutrons, N, is equal to A minus Z. So what we need to do now is to subtract this from this. And you agree with me, if you do that, 238 minus 92, you're going to have 146. So you can see here, B is the answer. That is 146. Okay? Let's look at this. It says, sorry, this is a body. This is a body. A body moves with a constant speed, but has an acceleration. This is possible if it A, moves in a straight line, B, in oscillating, C, moves in a cycle, D, has a varying acceleration. One thing you should know is that when we talk about has an acceleration, it means there is a change in velocity. Okay? But the speed is said to be constant. The only way this can be possible is when something is moving in a cycle. The speed is the same. But why the speed is the same? You are not increasing the movement of your hands. Something is changing. As I'm moving my hand, what is changing? Or if I'm doing like this, what is changing? The direction. See? The direction. The direction. I'm not moving straight. I'm moving, the direction is changing. It means that while the speed is constant, the velocity is not constant. Why? Because velocity is what? It's a vector quantity that has direction. That is the displacement over time. That displacement is changing direction. Because it's changing direction, it means what? This guy, which is actually a component of acceleration, is actually changing. Because of that, we say what? Acceleration is changing, speed is constant. But what was I doing? It was moving in a cycle. Therefore, this is the answer. Let's look at this. It says, a ball is projected horizontally from the top of a hill with a velocity of 20 meters per second. If it reaches the ground 4 seconds later, what is the height of the hill? What is the height of the hill? We are simply going to use this formula that says this is equal to ut over 1 over 2 at squared. Because we are talking about height, we replace this with this, then we put this u, initial velocity plus 1 over 2, this becomes g t squared. We are looking for height, right? Initial velocity from this information is 0 because we have it first in my hand before I threw it. Okay? Before what? It was projected. 0, then final velocity is there. So 0 multiplied by t, 1 over 2. What is g? Let's take 10 to be g. And the time is after 4 seconds. 4 square. This simply means 5 times 16, which is equals to 80 meters. One thing you should notice is that we did not even touch this. This is a trap. Because this is final velocity. There's no final velocity here. This is what? A trap. To see if you know what you are doing. So the answer therefore is D. Let's look at this. It says what? The product PV, where P is pressure and V is volume, had the same unit as any of this. Let's investigate. What is pressure? Pressure is force over area. The force exerted on the surface over the area. Okay? What is the unit of pressure here now? You agree with me that this is Newton. This is what? Meter square. It therefore means that pressure, the unit of pressure is Newton per meter square. That is meter raised to power minus 2. You agree with me volume is meter raised to power 3. Okay? Now we are told PV. PV, that is, if you combine these two together, that is their unit. You agree with me that this is minus 2 multiplied by this raised to power 3. If you use indices, you agree with me that this will amount to raised to power 1. Then we leave it like, what is Newton meter? Newton meter is joules. Okay, it therefore means that what? We are talking about work. Let's look at this. It says what? An image which can be formed on a screen is said to be what? Image that can be formed on a screen is said to be real. Okay? But if the image cannot be formed, it's said to be virtual. So therefore, C is the answer. Okay? Which of the following is stored by dry Laplace cell? It is what? Chemical energy. Chemical energy. It is this chemical energy we convert to electrical energy. Okay? We convert this chemical energy to electrical energy. Let's look at this. It says what? A given mass of gas at a temperature of 30 degrees Celsius is trapped in a tube of volume of V. Calculate the temperature of the gas when volume is reduced to 2/3 of its original value by applied pressure twice the original. Apply pressure twice the original. All we have to do, first of all, is to remember the gas equation. What is gas equation all about? It says P1 V1 all over T1 is equals to P2 V2 all over T2. That's what? The gas law. The next thing we need to do now is to ask ourselves, what are we looking for? Calculate the temperature. We know the first temperature, the second temperature. Let's make this one the subject of formula. Without wasting our time, if you want to make this the subject of formula, you agree with me, is simply T2 is equals to P2 V2. Then this comes here. Then these guys come down. Okay? It is time for us to start substituting. The first one we need to, first of all, ask ourselves, what is P2? This P2. A given mass at a given temperature, it traps whatever. Calculate the temperature, whatever. If what? The volume is reduced to this of its original, but pressure is twice the original. Okay? So this one is 2 times the original, 2 times P1. Okay? Multiply by the V2. What is the second volume? The second volume is 2/3 of the original. 2/3 of the original. Okay? What about the temperature? The temperature that was given to us to be what? 30. So what do? We simply add 273 to it to turn it to Kelvin. This plus 273 to become 303. Okay? We are turning it to Kelvin. So therefore, this is 303 all over. We don't need to waste our time again. We put P1 V1 because we can easily cancel these guys. Okay? This becomes 4 over 3 multiplied by 303. 3 here, 1, 3 here is 101. This will give us 404. Okay? So with this 404 now, temperature is still in Kelvin because we converted the original to Kelvin. Therefore, what we need to do, we remove 273 from this. 404 minus 273. Just to convert it back to Celsius. And you agree with me, if you subtract this now, you're going to have 131. So therefore, this is the answer. Okay? That is 131. Hope you understand this. The function of manganese 4 oxide in lackless cell is what? Always remember that cell, they have two defects, okay? They have two defects. The first defect is always local action. Local action. Why the second one is what? Polarization. Okay? To prevent this guy, you simply use what? You use pure zinc. Why this? We use manganese 4 oxide. So this is used to prevent C. Okay? Let's look at this. It says what? It says the density of water is 1 gram per centimeter cube. Calculate the change in volume when 90 grams of ice completely melted. No problem. One thing you should know is that when you want to calculate the volume of ice, remember to put this as equals to mass of the ice all over the density of the ice. So you can see from here now we know the mass to be 90 grams. The density of ice by default is 0.9 gram per centimeter cube. So therefore, we're going to put here 0.9 gram per cm cube. It means therefore, if you calculate this now, you're going to have this to be 900 over 9 in cm cube, because this and this will cancel. This will give us 100 cm cube. That is the volume. Okay? Then we go for the water now. The same thing for the water. The volume of water is equal to the mass of the water all over the density of water. Now, remember it is the ice, the same ice that was melted. It means we are still looking at the same mass now. This is the ice melted. So it's the quantity of ice that was turned to water. So therefore, it's still 90 grams. But what is the density of water? The density of water was given to us specifically to be this. So that is put one here. You agree with me at the end of the day, you're going to have 90 cm cube. Okay? So we have that of ice, we have that of water. The question says change in volume, meaning what is the difference? It's 10 cm cube. Difference between these two. So C is the answer. Okay? The answer is C. Let's look at this question. It says what? A hygrometer is an instrument used to measure what? This question is very tricky because they are saying hygrometer. Some students will be thinking that this is talking about what? Hydrometer. That is, in place of this, we put D. When you put D here, that is hydrometer, it means you want to measure relative density. Which is this. But this is hygrometer. Hygrometer is mainly used to measure what? Relative humidity. So the answer is D. Let's look at this question. It says what? In the diagram below, the current I is what? This current is what? All you need to do, what is the total resistance in the system? Remember, current is V over R. What is R first? Because we already know this to be 2. What is this? Because they are in parallel. Remember, I taught parallel a lot. Parallel is when you connect two things like this. Connect this end at this end. Series is when you connect one, you connect another one, you connect another one. But this is parallel. When it is parallel, all you simply do is 1 over R equals to 1 over 3 plus 1 over 6. SCM, you agree with me, this is 2 plus 1, which is 3 over 6. That's 1 over R. Cross multiply R, therefore, is 6 over 3, which is what? Which is simply 2. It means here is also 2. This is 1 amps. Okay? 1.0. The answer is A. Okay? The answer is what? A. Hope you understand this. Let's look at this. It says what? Calculate the peak voltage of a main supply of RMS value of 220 volts. All you have to remember is to get the peak, that is the peak voltage, is always equal to the RMS voltage multiplied by the square root of 2. What was given to us was 220 for RMS multiplied by square root of 2. So all you have to do now is to calculate the square root of 2. Square root of 2 relatively is 1.414. If you multiply these two, approximately you're going to have 311 in voltage. A is the answer. Okay? That is approximately 311. Hope you understand this. Let's look at this. It says what? To obtain a maximum horizontal range for a projectile, it must be launched at an angle to the horizontal. The angle is what? Always 45 degrees to the horizontal. Okay? No need to waste your time here. Remember that to have the maximum range. Maximum range. This is constant, non-negotiable. Okay? Let's look at this. It says what? 2 points A and B are 1 meter apart. 2 points are 1 meter apart. So the distance between this is 1.0 meter. Okay? What is the least frequency that will resonate with a wire stretched between the 2 points? You put a wire here now. You agree with me? You stretch it up. You release it. What will happen? The wire will make this type of wave. Okay? Stretch it up. What this is telling us is this length is equal to wavelength over 4. Okay? Wavelength over 4 with this information. Now we are looking for the wavelength. We know that if you cross multiply, you're going to have 4L. 4 multiplied by this 1 to get 4 meter. Okay? The next thing we need to do now is to know that frequency is equals to velocity over wavelength. Okay? Velocity over wavelength. We are given the speed, which is actually 200 meters per second. We know this to be 4. You agree with me? If you divide this, you're going to have 50. Okay? That is 50 hertz. Which of them is 50? A is 50. Okay? A is 50. Hope you understand this. Look at this question. It says an ebonite rod is rubbed with a 4. It is true that A, the 4 will acquire positive charges, while the rod will acquire negative charges. This is actually the answer without wasting our time. All this other one can be optional. So know that whenever an ebonite rod is rubbed with a 4, what will happen is that the 4 will definitely acquire positive charge, while the ebonite itself will acquire negative charges. Okay? Let's look at this. It says what? Given that the decay constant of a radioactive element is this, its half-life is what? Half-life. Half-life is always the time, that is half-life, is equal to ln 2, that is natural logarithm 2, ln 2 over this, the decay constant. This is the decay constant. This is 693. This is a constant value. You can't change it, okay? Now, what is this? We are given this to be what? This value, okay? That is 0.055. 0.055, okay? Approximately 12.6 seconds. That is this. Okay? Let's continue. A ball of mass 2 kg hit a wall with a horizontal speed 10 meters per second and rebounds with the same speed. The impulse experienced by the wall is what? You hit the wall. What impulse was experienced by the wall? What is impulse? Impulse is always mass multiplied by change in velocity. So what is the mass? The mass is 2 kg multiplied by this, change in velocity. What is the change in velocity? To get the change in velocity, we have to say the final velocity minus what? the initial. Okay? And you agree with me that with the information given to us, same velocity. Initial, the one you used to throw it, that was what? 10. The final, returning back to you, that is negative. Direction. Remember, velocity is what? A vector quantity. You hit it positive, bounce back, negative. So here, it's minus 10. What it means is therefore is 2, which will give us minus 40. But one thing about impulse, we are interested in the magnitude. The magnitude. Therefore, we need to calculate the absolute value of this, which is 40. So the answer is this, 40 Newton per second. Let's look at this. It says what? Determine the magnitude of the acceleration of an object of mass 5 kg, which is being acted upon by two forces, each of magnitude 50 Newton, acting perpendicularly to each other. One thing you should know is that we have two forces. They are both 50 Newton. They are acting perpendicularly to each other, meaning that one is on this side, one is like this. So to actually get the resultant is at the center. So we project this like this now to say, can you even write it, do it like this? Because what we are going to get here is 50 Newton, 50 Newton. So this can be transferred here to be 50 Newton. So we are looking for this now. Okay, this. So all you need to do to get this, say 50 square, 50 square, using the Pythagoras theorem. If you work on this now, you're going to have, let's just say 2 multiplied by 50 square. You agree with me? We can separate it to the square root of 2 multiplied by square root of 50 square. Okay? This and this will cancel to have 50 square root of 2. Okay? Now that we have this, the question says what? Determine the magnitude of what? Of acceleration of mass 5 kg. What is force? Force is ma. We are looking for acceleration, which is F over m. What is F? Is this one, because resultant force and the mass is 5. So this is telling you now that what? This is 10. That is 10 square root of 2. You solve this now, you're going to have 40.14 meter per second square. So the answer is approximately this, C. Hope you understand this. This is where you should first of all know what to do. Resultant force. Okay? Or the effective force of these two perpendicular forces. Once you do that, this is easy. Substitute, you get your answer. Okay? Let's look at this. What is it saying? It's saying, given that the radius of the Earth is this, and the acceleration due to gravity is this, determine the escape velocity of an object on the surface of the Earth. To do this, escape velocity is equal to square root of 2 gr. This formula is very important. You remember it. So we put 2, we put 10, this and this. Then we put the radius, which is 6400. The rest is just calculation, okay? You agree with me? We are told that this is what? In kilometer. So we have to multiply by 10 to the power minus 3, okay? Now, let's take all the zeros together. That is 2 multiplied by 6, 4, 1, 2, 3. Join this to become this. If you multiply this now, you're going to have 128. Multiply by 10 to the power this. What I will simply do is to do square root of 128 times square root of this. That is 10 to the power 6 divided by 2. Because this square root is actually raised to power over 2. It means, therefore, here now we're going to get the square root of 128 multiplied by 10 to the power 3. Okay? So now, the square root of 128 is 11.31 multiplied multiply by this. If you check the answer now, you find that the only correct answer here is this. Why is it? Because this is kilometer. So this one alone is already kilometer. That is 11.31 kilometer per seconds. Okay? So D is the answer. Okay? Remember, kilometer per seconds. K per 1,000. Meter per second still remaining. Because the original question was meter per second square. Please know your unit and how to cover them, okay? Okay, which of the parts will electric charge tend to concentrate most? It is always the sharpest part, the sharpest. You agree with me? This is the sharpest, so don't waste your time, okay? Let's look at this. It says what? In the wavefront shown above, this is below anyway, it was there before. Energy is transferred from A to B in 0.05 seconds. What is the frequency of the wave? The frequency of the wave is equal to the number of cycles all over time. How many cycles are you seeing here? That is 1, 2, 3. This is half. That is 3.5. All over. If you calculate this now, you agree with me, you're going to have 350 over 5, which is 70. I will have 70 here. 70 Hertz. B is the answer. Okay? Let's look at this. Anomalous behavior of water occurs in the temperature range of what? This is a repetition of the previous year. That's why I said repetition. You will see at least 1 or 2, 3, 4. The answer is simple. It's always from 0 to 4. Let's look at this. It says the pitch of a note depends on what? The pitch of a note always depends on the frequency. Depends on the frequency. So don't waste your time, okay? Let's look at this. It says what? An erect image 4 times as big as the object is formed by a lens of focal length of 50.0 centimeter. What is the image distance from the lens? Don't forget that focal length, that is 1 over focal length, is equal to 1 over u plus 1 over v. Okay? U is the size of the object, v is the size of the image. As you can see here, we have 15 for the focal length. We don't know the original size. We are told that the image is 4 times as big as the object. But what you must put at the back of your mind is this is minus. Okay, minus. Therefore, it's 1 over u minus 1 over 4u. So what we need to do now, we continue. If you solve this now, you agree with me. This will simply give us 4u, 4 minus 1, which is 3 over 4u, equals to 1 over 15. You cross multiply, it's 4u equals to 3 times 15, which is 45. It means that 4u is equals to 45. We are told that the image is 4 times. Okay? So the meaning of 4 times is 45. Because the question says what? What is the image distance from the lens? Let's look at this. It says what? 100 complete waves pass a given point 5 seconds. Given that the distance between 2 consecutive crests of the wave is 11 meters, what is the speed of the wave? The speed of the wave. The speed of the wave. To get the speed of the wave, you agree with me, is always like this. Okay? But the first thing now is that what is the frequency? The frequency is equal to the number of waves all over time. How many number? We have 100. How many at the time is 5. And you agree with me, if you divide this, you're going to have 20 Hertz. So now let's go back to this that says V is equals to We now have this to be 20. We have this, the distance between two consecutive crests. If I have this, that's what? Full wavelength. That is half of it. This half. This another half. So here to here is given to be 11. That is what? This. You get this to be a meter per seconds. So this is the answer. Let's look at this. It says what? Given that the speed of light is 300 million meters per seconds. Million, don't forget the million. Calculate the energy released in a nuclear reaction where the mass defect is this. Einstein equation simply say what? This is equal to mc raised to power 2. Okay? The first thing we need to ask ourselves, what is the mass? The mass is this. Let's just put it straight to be 1.0 multiplied by 10 raised to power minus 5. What is the speed of light? The speed of light is 300 million. Million is what? How many? 6. We square it. The rest is just calculation. This one simply means 1 over 10 raised to power. This means, this one on the inside means times 10 raised to power 8. To square it. You agree with me that this will give us, put 2 here now, you have 9. Here you have 16. Okay? And you agree with me, 5 here we remove 5 to remain what? Raised to power 11. So this is actually the answer. This 5 we remove 5 from here, remain 11. This is not touched. Okay? In joules. So as you can see here, A is the answer. Okay? Let's look at this. It says what? The property of waves which can be used to differentiate light wave from sound wave is what? The property that can be used is called what? Polarization. Polarization. Because light can be polarized, but sound cannot be polarized. Okay? Let's look at it. It says the electromagnetic radiation with the shortest wavelength is what? If you have watched my last video, 290 physics question, you see that I told us how to get this from the least to the highest. The first one we saw was gamma rays. So if you have not watched it, please go and watch it. So no need to waste our time now. Go and watch it. I listed all of them. Gamma ray. Hope you enjoyed this class. Please, if you have not subscribed, subscribe to this channel. Share this with your friends. Thank you.